Today we're going to be working on simplifying exponential expressions with different properties of positive, negative, zero, and integer exponents. So let's think about what we've done before in the past. We're talking about exponents. Here we've got x to the eighth. We have to think about, well, what does this mean for us? And so this is going back to vocabulary. X is referred to as the base, and 8 is your exponent, or the power. X to the eighth means you have 8 x's being multiplied together. We use exponents as a way to shorten repeated multiplication for our problems. So when we have something like 3 to the fourth, we want to think about the meaning. Well, our base is 3, our exponent is 4. Therefore, 3 to the fourth means you have 4 3's being multiplied together. Well, we know 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So 3 to the fourth is equivalent to 81. Well, we also have negative 6 squared. So we want to think about what this means. This means we have 2 sets of negative 6 being multiplied together. So if we think about the meaning and write it out according to that, negative 6 times negative 6 is 36. So let's try a couple. We want to write out the meaning of each term and simplify it. So when we have something like v to the third times v to the squared, that means I have 3 v's being multiplied together and then 2 more v's being multiplied together. Well, if I have 3 v's and 2 v's, that means I would have 5 v's total. When I have something like x to the sixth, that means I have 6 x's being multiplied together times another x. Therefore, I have 7 x's being multiplied together, and I represent that by x to the seventh. When I have 2 to the third, that means I have 3 2's being multiplied together, followed by another 3 sets of 2's being multiplied together. That means I have 6 2's being multiplied together, which is equivalent to a value of 64. Well, as we were writing about based on the definitions, is there a pattern that you saw when you're multiplying your exponents? Hopefully you saw that when you have the same base, and they're both raised to a power and exponent, to get your final results as above, you ended up adding your total items together. So So the base of a to whatever power of m times the base of a to whatever power of n, by adding those two together resulted in our answer. So if we go back and look above, v to the third times v to the second, that was v to the fifth. 3 plus 2 is 5. X to the sixth times x to the first, 6 plus 1 is 7. 2 to the third times 2 to the third, well, 3 plus 3 is 6. This just happens to have a value of 64. So when you're multiplying like bases, instead of writing out everything in expanded form to find the solution, we could just add the exponents together. Let's take a look at a couple of other exponential expressions, and let's think about the meaning for each of those and notice if any patterns exist. So here we have m to the fourth to the second power. So again, thinking about the definition of the exponent, it tells you how many of the base that we have. So this is saying I have 2 sets of 4 m's. So if we write that twice, what will that leave us with? So 2 sets of m to the fourth. Well, m to the fourth means I have 4 m's being multiplied together, and m to the fourth means I have another 4 m's being multiplied together. That means I have a total of 8 m's being multiplied together. Let's see how you do on the next two. Can you write out the meaning for each term and then simplify? Here we have x to the second to the third. That means I have 3 sets of what's on the inside. So if I write it out 3 times and think about the meaning, I have a total of 6 x's, which can be represented by x to the sixth. For part C, I have 4 to the third, which means I have 3 sets on the inside. So that means I have 4 to the third times 4 to the third times 4 to the third. But we know 4 to the third means you have 3 4s being multiplied together. So again, if I write that out, 3 sets of 4, 3 sets of 4, 3 sets of 4, you have a total of 9. And we know 4 to the ninth is worth 262,144. So again, whenever we're thinking about the definitions in mathematics, it's just patterns. So again, we want to see, is there a pattern for exponents raised to exponents? So we started off with m to the fourth to the second. We ended up with m to the eighth. X to the second to the third ended up as x to the sixth. 4 to the third ended up as 4 to the ninth, which has a value. Hopefully you can see that this is telling you how many of this that you have. 2 sets of 4, 3 sets of 2, 3 sets of 3. So when you've got that base of a power raised to a power, you just end up multiplying the exponents together. So let's have you try these. Write out the meaning of each term and simplify. Again, we're looking for any patterns that may exist. For A, we have x squared y to the third to the second. And so what we talked about before, this tells us how many of the inside that we have. So if I write it out twice, I can see if I can simplify it any further than it already is. It means I'll have x squared, y to the third, y to the third. So if I look at how many x's I have, x squared, there's 2 here, x squared, there's 2 here, I have a total of 4. Y to the third, there's 3 here, and y to the third, there's 3 there, for a total of 6. So I ended up with x to the fourth, y to the sixth. For our second one, we've got m to the third n to the third power, which means we have 3 sets of the inside. So if I write it out 3 times and try simplifying it, I've got m to the third, m to the third, m to the third. It means I have 3 here, and another 3 here for a total of 6, and another 3 here for a total of 9. And then I've got n times n times n for a total of 3. So I've got m to the ninth and n to the third. Our third set, we've got 3x squared squared. So again, I have 2 sets of the inside. So I've got 2 3's. Well, 3 times 3, that's 9. X squared and x squared, 2 here and 2 here for a total of 4. So I've got 9x to the fourth. So when we had multiple variables or multiple items raised to a power, was there any pattern? So again, as we look, x squared y to the third squared ended up with x to the fourth y to the sixth. M to the third n to the third ended up as m to the ninth n to the third. And we had 3x squared ended up as 3 squared x to the fourth, or 9x to the fourth. Again, since we're saying how many sets of the inside, that's a product of what we are working with. So we're taking each item inside those parentheses to the power. So you're raising a power to a power. You're multiplying them together. So just make sure you're distributing each term inside your parentheses. So here we have a mixed variety. Can you simplify the expressions? B times b to the third, that should be b to the fourth. Y to the third times y to the fourth should be y to the seventh. Negative 3x to the third times 4x to the second should be negative 12x to the fifth. Let's try a few more. Two x to the third y squared squared should give us 4x to the sixth y to the fourth. Negative 4xy squared to the third should give us negative 64 x to the third y to the sixth. We've got ab squared to the third times a to the fourth b. That should give us a to the seventh, b to the fifth. Utilizing the patterns that we've learned today with working on simplifying our exponential expressions, you're going to continue to practice on your Unit 5 Day 1 worksheet. If you need to write out the meaning for each expression, please do so to guarantee that you're coming up with the correct simplified form. If you do not need to show as much work, that is fine as well, but our goal is to do this accurately.